In this video, we'll be talking about chi-square distribution and we'll be doing a problem about goodness of fit. Okay, so goodness of fit is an inferential procedure to determine whether a frequency follows a claimed distribution. So what happens is we assume or we logically theorize that something will occur, and we'll try to compare that with the observed values. Okay, the observed values versus the expected values. The expected values are what we think that could be possible. Okay, so chi-square distribution, it's not symmetrical if you graph it, and its shape depends upon the degrees of freedom. And degrees of freedom, by now you already know, it is already always n-1, the total sample size. Now here in chi-square distribution, we say number of categories, okay, number of different categories, -1, but the values are nearly similar. Okay, the idea is same. Now as the degrees of freedom increase, the distribution becomes much more symmetrical. Okay, so again the central limit theorem comes into play here as well. Test statistic is calculated in this way. This is Greek letter chi square equals to sum of all observed values minus expected values squared divided by expected values. Okay, so this I runs from 1 up to n. All right, so if there are n number of categories, then it runs from 1, 2, 3 up to n. Okay? So O means observed values, that's the real values. E means expected, or whatever we have assumed in our logical manner. And for the p-values, we don't go for tables or anything. We will just simply use the GeoGebra probability calculator, and we will see how that is done. To use this chi-square distribution or chi-square test, we must acknowledge that all the expected counts must be greater than or equals to 5. And for this distribution, the population mean is the degrees of freedom, and the population standard deviation is root under twice the degrees of freedom. We first need to set up two contradictory hypotheses, null and alternative, for mean, proportion, or chi-square or anything, and then collect the sample data, or in case of chi-square distribution, the observed data is given and we need to go for expected values. Okay, and then we need to determine whether the correct, or what is the correct distribution to perform the hypothesis test. Now usually in chi-square distribution, the graph is right-tailed, so we would go for one-tailed test, okay, or right-tailed test. And then after that, we need to determine the test statistics. Now if it were the normal distribution, we would go for G value. Student distribution, then we would go for T value. If it were proportion distribution, then again we would go for G value, okay, if the underlying distribution is normal. And here for chi-square distribution, we will go for this chi-square. That's the test statistic. Usually the significance level is given. If it is not given, then by default we consider alpha equals to 0.05. That's 5%, okay, or 95% significance level. And this will help us to reject or not to reject the null hypothesis. Then alpha is the significance level, which is the probability of type 1 error. P-value, that's the probability of event that will happen purely by chance, using the null hypothesis tree. Now once the p-value is already figured out, then you will compare that with alpha. If it is greater than p-value, then we would reject the null hypothesis. If alpha is less than or equals to p-value, we do not reject the null hypothesis. And then finally, in conclusion, we will always talk about the alternative hypothesis, okay, stating that at the say 95% level of confidence from the sample data, there is no sufficient evidence to conclude that alternative hypothesis occurs, or there is sufficient evidence to conclude that alternative hypothesis. So now let's head over to one of the examples that I took from the book. Teachers want to know which night each week their students are doing most of their homework. Most teachers think that students do homework equally throughout the week. Suppose a random sample of 56 students were asked on which night of the week they did the most homework. The results were distributed as follows. Okay. So here, so this is how the distribution follows. Okay, so there are 7 categories: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. observed values are 11. These are the real values, and what is the expected values. Okay, so we will talk about that. So 56 is the total, right? And here also expected value also should be 56. And here the teacher is thinking that, most teacher thinks that students do homework equally throughout the week. So that means the expected values are equal throughout all the categories, means throughout all the nights. Okay, all these days or nights. Since there are 7 days, so we would simply go for 56 divided by 7, which is 7, 7, 7, 49, 7, 8, 56. So 8 on each. Okay, so this is 8. So this is how we come across expected value. Expected value is always obtained from the given statement. Okay, so null hypothesis is probability of doing the homework on Monday, probability of doing the homework on Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So that is almost 1/7, right? So that's how the null hypothesis is formed. Okay, since the teachers are thinking that students are doing their homework equally throughout each of the day of the week. All days are equally likely. Now, what would be the alternative hypothesis? Okay, alternative hypothesis is a contradictory statement to this one. Okay, so at least one day in a week does not follow the equal distribution. That means at least one of the days don't have equal frequency or equal probability. Okay, then now we will go for finding out the test statistics, p-value. Since here we are talking about observed values and expected values, so it's always logical to go for chi-square test. Okay, and let us find out the t statistics and p-value. Okay, so number 2, and since the significance level is not given, we will assume that alpha is 0.05 or significance level 95%. Okay, by default. To find the test statistics and p-value, we would go to GeoGebra probability calculator, and we will assume that alpha is 0.05, the significance level is 95%, since it is not given. Okay, so go to this probability calculator, statistic, and go for drop down menu, go for goodness of fit. Okay, there is chi-square test and goodness of fit. I would ask you to go for goodness of fit, and then since we know that there are 7 categories, right? Mondays up to Sunday, that's 7 categories. So just go for drop down menu, go for 7 categories, observed count. Okay, so for observed count, let us see what are there. 11, 8, 10, 7, 11, 8, 10, 7. Okay, so first of all, let me go for that. Okay, so observed counts are we have already written down the observed count, and expected count is 8 for all of them, right? Then you can clearly see that the degrees of freedom is of course 6, since total categories are 7. The test statistic, the chi-square, is 4.5, and the p-value is 0.6093. And now we can say degrees of freedom is of course 7 minus 1 equals to 6. Chi-square is what? And the p-value is 0.6093. Alpha equals to 0.05 is less than p, which is 0.6093. Since alpha is less than p-value, so we do not reject the null hypothesis. So in conclusion, for 95% significance level, there is no sufficient evidence to support that at least one of the days follows an equal distribution. Okay, so this is the way how we go for goodness of fit, and I hope you got the point. Thank you.